Okay, I'm just going to do a quick little video relating to the central limit distribution, sampling distributions. I included these notes, and in the notes they were going to talk about a problem where the mean has value 700, standard deviation I believe is like 150. Yeah, sample size is 30, and what's the probability that a sample mean will fall between 680 and 690? So we're talking about sample means now, and that brings in the central limit theorem. And the central limit theorem is saying that if you take samples of a certain size, 30 or larger, as you look at all the sample means from those samples of size 30, then those sample means will form a distribution that is approximately normal. And the mean of that distribution will be the same as the original mean, so in this case 700, but the standard deviation will be equal to sigma over square root of n. And so 150 over square root of 30 in this case, because their sample size is 30. 30 is typically the value they give. It doesn't need to be 30. It can be smaller, just depends how normal they are to begin with. But what that tells me is if I want to answer this question about the probability that a sample mean drawn from this population of a sample of size 30 is between 680 and 690, then using StatCrunch, move this up so we can see it, so go on to Stat, Calculator, Normal. First thing I'm going to do here, let's get this so I can see it, is put in my mean and my new standard deviation, which is 150 divided by the square root of 30, or 27.4. So this is what you have to change. The standard deviation is no longer the 150, since we're talking about the means. In this case, I want what's the probability that a mean is between 680 and 690, so I'm going to go to between 680, 690, compute. So if I scroll back over to my other sheet, I'm saying it should be around 12.48. And what do you know? Same thing I got on my notes when I did it before. So don't make these difficult. If they're asking you about probability for a sample mean, then you take the mean, you take the standard deviation of the population, divided by the square root of the sample size, and you know that distribution will be approximately normal. You could have something with a mean and standard deviation, you don't know how it's distributed, but as soon as you start talking sample means, as long as your sample size is large enough, the distribution of sample means will be approximately normal. So don't overcomplicate it. It's what you've been doing with the change of your standard deviation.